Okay, so the next thing we're going to do is something else we have to know how to do. These are PWM Talon FXs. We are almost never going to use a motor in PWM mode. Almost never. I say almost never because there are some use cases for it, but by and large, we're going to be using motors on the CAN bus. Now, the difference being, who knows the difference between using the motor in PWM and using the motor in CAN? Who knows the difference between PWM and CAN? So one way to control motors and other devices is through what's called PWM. That stands for pulse, width, modulation, which does sound like a big word. It's not really that impressive. The idea is you're sending a signal with highs and lows, and you're varying how far apart the highs and lows are. That's pulse width modulation. Because it's so simple, you can't send a lot of information forward or back with it. You can send enough. You can send enough to make the motor spin and do all that fun stuff. But that's about all you can do. Another option is called CAN. And CAN is a controller area network. And this acts a lot more, for lack of a better term, like the internet, right? You've got multiple devices that are connected to each other, and they can send messages back and forth. At one end of the CAN bus, you've got the main CPU, the RoboRio. And along the CAN bus, you've got, let's say, motor controllers. The RoboRio can say, you got motor controller 1, 2, and 3. The CPU can say, hey, I want motor controller 3 to spin at 500 RPM. And it can send that message along the CAN bus, and it will stop when it gets to motor number 3. Motor number 3 can also say, hey, whoever's listening, this is how many turns I've made. And that message can go back along the CAN bus, back to the CPU. So you can send a lot more data and a lot more kinds of data. And for that reason, you get a lot better control of your devices when they're on CAN, and you're able to control them a little bit more separately of the CPU. If you're using PWM, for example, the CPU is going to have to be doing all the calculations telling the motor exactly how fast to go. If you're using CAN, you can send a CAN signal to the motor controller saying, hey, I want you to be doing this general thing. I want you to handle the math, which is nice because it offloads a lot of the work that your CPU has to do onto the motor controller, which is more specialized anyway. Is anybody not convinced that CAN is better? I really want to drive that point home. CAN is better in almost every way. The one downside of CAN, if there is a downside, if something is operating in PWM, that means every single motor gets a wire going back to the CPU, which means if you cut one of those wires, you lose that one motor. The CAN bus, however, is a daisy chain, which means you don't wire every motor back to the CPU. You just wire the motor to the next motor, and so on and so forth, which means if you break the chain here, you don't lose that one motor. You lose that one motor and everything after it. Again, it's not a problem if you have good, robust, resilient wiring, but it is something extra to keep in mind.
So let's say we have 4 motors, and then in CAN we cut off like at motor 3, you lose like between.
Yeah, so if I've got the Rio, I've got motor 0, motor 1, motor 2, motor 3, and then I've got the thing at the end of the CAN bus, right? It's going to basically be wired like this.
So if you cut like the middle between 2 and 3, you lose 3 and the what
Yeah, so 0, 1, and 2 would probably still be good, but 3 would go down, any devices after 3. If you cut it here, 0 and 1 are still good, 2 and 3 go down, anything after 3 goes down. Again, because it's a daisy chain topology, it's just one thing to the next thing.
So don't cut it.
Don't cut anything, yeah.
Could you add a second PWM system? So if the CAN chain breaks, you can then use PWM?
I think you could do that. Now, again, remember, if you're operating in PWM, you lose like 90% of your control options. You're back to having to do the calculations by hand.
Let's say that chain gets broken, then you can have a secondary system use to still be able to.
I think you could. I think you would be better off designing your wiring so that that wouldn't happen than trying to have a software backup. In my experience, but I believe you could do that in theory. So here's the problem with CAN though. The CAN libraries are not in WPILib. They are not a built-in part of WPILib. Now, they use parts of WPILib so that you can drop them in as an exact replacement for a PWM device, but they're not already in there. You have to go to the vendor and get them from the vendor, which isn't really that big of a problem. It's just if you don't know that you need to do it or you don't know how to do it, it's hard. So here's what we're going to do. We're going to replace our PWM Talon FXs with CAN Talon FXs. But again, the problem is CAN Talon FXs are not part of WPILib. It's a third-party library. So anytime you need a third-party library, here's what I do. I fire up my web browser. And after it decides to update, because I haven't used this computer in a few days,
A very slow web browser.
I had to run an update. I just looked for WPILib vendor dependencies. And the first thing that comes up is going to be third-party libraries from WPILib docs. And there's going to be a whole bunch of them on here. And it tells you exactly how to go through it. And at the bottom, it's actually got some of them. And so what's going to matter for doing this is when you're using the device is knowing who makes the device. Does anybody know who makes the Talon FX?
Corporation that owns the motors.
The company that owns that motor controller. So that motor controller is made by Cross the Road Electronics. So if I'm looking in here, I'm hopefully going to find something from Cross the Road Electronics. Nothing from Cross the Road. Now, I also happen to know that Cross the Road Electronics is often referred to by their acronym CTRE. And here I can see, okay, the CTRE Phoenix framework. And there's two URLs here. There's Phoenix v6 and Phoenix v5. Which one do we use? All users should use the Phoenix v6 library. That's because Phoenix v5 does not exist in the 2025 season or later. So all we have to do is copy this URL, this HTTPS Maven, all the way over, and we'll just copy that. So once you have that, you go back to your project, and then we go into the WPILib icon, and we're going to look for the word vendor. And you should see manage vendor libraries. There should be several options. Because we're going to be using the URL, we're going to install a new library online. And then we just paste that URL that we copied. And if it's mildly successful, say, hey, you should do a build. Let's do a build. And so what it's doing now is it's going to that URL and it's going to be pulling down the packages. So it's going to be pulling down libraries that we don't already have. So it will take a little bit longer than most builds, but again, shouldn't take too long. Word of advice here is you might run into problems with some of these, especially on the school network. It's not something that I've consistently run into, but it is a thing that I have run into. So these are all things you want to make sure you do in advance the first time whenever you can. Mine already finished. Are y'all's done or y'all still going?
Mine's
Mine's been
Okay, good. Now, my code hasn't changed. I have not used those yet, but if you look in your files, there should be a folder called vendor deps, and you should now see a file in there called phoenix6.json. This isn't really anything for you to like worry about or to know how to interact with. It's just saying, hey, you added this vendor dependency, so now you can use all this cool stuff. Okay, so now we got to make some changes. We're in our drive subsystem. Now here's what's going to be nice about this. The only file we have to touch to make this change is the drive subsystem. We don't have to change any other part of the code because no other part of the code cares that we're using PWM Talon FXs. What are we using instead? Can. Talon. Where is it? It's not showing up.
import.
That's because it's not called a can Talon FX. It's just called a Talon FX. So we'll change all four of these.
Can you just press F2?
No, because we don't want to rename the type. We need to change the variable type. If you pressed F2, it would try to rename the PWM Talon FX in WPILib. Now, if I do that, though, it's going to break these because I'm not making new PWM Talon FXs anymore. I'm making new Talon FXs.
I made a mistake.
Can you just delete the PWM?
You could.
Hey,
And that's it. This is now set up to use can Talon FXs. Now, there's a lot more you can do to this configuration, but this is all you have to do to change that. So if I were to run my simulation now, simulate robot code, and I'm just going to do the sim GUI. I'm not going to use the driver station right now. Notice I don't have any PWM outputs anymore because the only 4 PWM devices I had are gone now. But notice on other devices, you should see a lot of things now. And so, for example, notice you'll see Talon FX V6 ID0, Talon FX V6 ID0 rotor sensor, forward limit, reverse limit. This is an example of that where you get all these other pieces of information just from using the CAN bus. So if you switch over to teleoperated now and wiggle your joystick around, you'll have to expand out those Talon FXs. But you'll see they also change just like the PWMs did. But you get a lot more information, like you get the supply voltage, the duty cycle, the motor voltage, the torque current, the supply current. The duty cycle is the one that'll tell you basically on a scale from 1 to -1 what it's doing. And it's not going to give you a full forward and full reverse on this one because it's doing a lot more simulation work than the old ones were doing. But that's how you can add CAN devices to your robot code, is by adding that vendor library. Let's add another one that we're going to need. So we're not using any rev devices right now in the code, but if I look back in those vendor libraries, there should be one in here from Rev Robotics. So I'm going to add this revlib to the project. Again, WPILib, manage vendor libraries, install new libraries online, paste the URL, make sure you don't have any extra spaces.
which one?
Rev Robotics. Yeah, the WPI, but
It's online.
yep, install online.
Won't be. I see.
And once this finishes, you'll be able to use Rev's devices on CAN.
I gotta get me one of these.
Those are actually pretty cheap. They're like 20, $30, and they sell them like on Amazon and at Best Buy.
I'm just gonna hook it up to my computer and
Yeah.
build the sim rig.
So that one finished on mine. If I go into the library, go into vendor depths, I can see, oh, there's RevLib. So I can use Rev's stuff now on the CAN bus. There are other things you can install with the vendor depths. It's not just CAN bus stuff, but the primary use most teams have for it is to use the CAN bus. Okay, any questions up to that point?